This was a sample that actually was in rows real-time, but for some reason we a bit forgot about it and never migrated it over to model real-time. But it's a bit interesting because it shows how you can integrate socket communication in closely with a controller in its event loop. And that is, for those of you who know about Connexys, which is our support for creating distributed applications, that is actually the mechanism how Connexys executables talk to each other. But here I'm using this demo for a different purpose. And in this demo, we have both a client application and a server application, and they have chosen to just put them here in the same folder. If we open them, we can see that they consist of some art files that is a little bit different for the client and the server, but there are some CVP files that are reused both in the client and server executable. So we have the UDP loop and we have the constants C++ file. If we open the server, we see that the same C++ files are used there, but slightly different art files. And if we open, for example, this UDP loop header file, we see that, or CP file, we see that it includes some header files from the target RTS. But right now, I have not set any of these TC files as active, and then I cannot right-click and cannot navigate to these header files. And the reason is that the C++ extension in this code, which here is the Microsoft C++ extension, it needs JSON files to know where, for example, these header files are located. And in the previous version of Code RealTime, it was the responsibility of the user to create these JSON files himself, which could have been okay if you just have one TC and you don't change the TC too often. But if you have multiple TCs and you change this T settings, then it's a bit cumbersome to have to do this manually. So now we have integrated the generation of these JSON files with the activation of the TC. So if I start by right-clicking on the client TC and marking it set as active, we see the checkbox comes here, and we also notice that this file was generated, C++ properties.json. So this is the file that the Microsoft language server uses for knowing where to find these include files and some other settings as well. There is a similar JSON file here, one level up, which is used by the CLangD language server. So we always generate both, but user would, of course, only have one of these installed at the same time. So in this case, this particular JSON file is unused since I'm using the Microsoft language server. And now if I again go back to my UDP loop, you can see now I get this navigation. I can control-click and navigate into target RTS header files. And also all the other editing features also start to work, like Content Assist and Hoover tooltips and everything. You see that there are some art files that are marked as errors, and that's because those particular art files, if you open one of them, do not belong to the client, but they belong to the server. So that's why in this configuration, these will be in error, because we don't generate what we need for those cases or those capsules. But if we instead make the other TC active, then you will see that now it's switched so that these are now correct and two other art files are now incorrect, which belong to the client. So this is probably not the way you would organize a realistic project, to have multiple executable TCs in the same folder. This is more to show that it's possible now. The better organization would probably be to have one workspace folder for each, one for the client and one for the server, and then you would create a library that contains the common code, which you would link with both the executables. Then you wouldn't need to switch here between active TCs and can have only one TC per workspace folder. Any questions on this feature?